Hi, welcome back to our software engineering series. In today's session, we are diving into the crucial topic of software quality assurance, SQA. We will explore the key elements of SQA, including quality attributes, process-based quality assurance, and the key goal of SQA's task. We will also discuss quality metrics, key quality standards, and the difference between the product and process standards. And we will provide an overview of how to create an effective SQA plan. By the end of this session, you will have a solid understanding of core concepts and practices that ensure software reliability, security, and performance. Let's get started. What is software quality assurance? SQA ensures software meets standard and fulfill customers' expectation. This leads to better user satisfaction and fewer post-development issues. Importance of SQA: by emphasizing SQA, organizations save time, reduce cost, and build trust with customer through consistent delivery of high quality software. Overview of SQA process. The SQA process provides a roadmap of consistent quality assurance. It ensures that potential risks are identified early, making the final product robust and dependable. Elements of software quality assurance. Standards serve as first is process definition and standard. Standards serve as a benchmark for quality, while well-defined processes ensure consistency and alignment with goals. They create a foundation of effective quality assurance. Quality control and testing. Quality control identifies defects early, ensuring functionality and reliability before release. Testing provides assurance that the product performs as intended. Continuous improvement make SQA a dynamic practice, allowing teams to adapt and refine their methods for better outcomes. Documentation and audits. Documentation ensures transparency and traceability, while audit verify adherence to standard and help uncover opportunities for process optimization. Quality attributes of software. Number one is functionality. Ensures that software meets user needs and requirement. Without it, the software fails to serve its core purpose. Reliability. Software builds trust by reducing the risk of downtime and ensuring dependable operation. Usability. A user-friendly design enhances satisfaction and drives adoption by making the software accessible and easy to use. Efficiency. Efficient software minimize resources consumption while maintaining speed, critical for high traffic or resource intensive applications. Maintainability software save time and cost in the long term, enabling seamless adoption to evolving business needs. Portability. The software portability ensures flexibility and extends the software's usability across various platforms or systems. Process-based quality assurance focus on process, documenting and standardizing process ensure consistency and reduce defects. Quality become an integral part of every development stage. Integration of SQA in development. Integrating SQA factors a culture of shared responsibility for quality, enhancing accountability across teams and improving the overall outcome. Importance of process model. Process model helps team align on best practices, streamline workflow and identify areas for improvement, ultimately leading to high quality software. Again, continuously improvement ensure that process evolve, adopting in changing requirement and fostering innovation while maintaining quality. Key goals of SQA task. Number one is defect prevention. Prevention defect is more efficient than resolving them post development. Early intervention save time, resources and maintain project momentum. Early detection of issues. Catching issues early ensures smooth progress, reducing delays, ensuring high quality outcomes. Compliance with the standards. Compliance is vital for trust and credibility. safeguarding both the company and its users while meeting legal requirements. Continuous process improvement of key goals. Continuous improvement foster innovation and adaptability, embedding quality into organization's culture. Customer satisfaction. SQA tasks directly impact customer perceptions, making quality a driver of business success and user trust. Reduction of cost. Effective SQA reduces overall expenses, ensuring that resources are utilized efficiently for maximum impact. Quality metrics in SQA. Defect density. Monitoring defect density highlights trends in code quality over time and assists in prioritizing area for refinement. Test coverage. Higher test coverage indicates thorough testing, reducing the likelihood of undetected defects and enhancing overall quality. Mean time to failure (MTTF). A higher MTTF indicates robust software reliability, crucial for user satisfaction and system dependability. Customer reported defects. Reducing customer reporting defects build trust, ensuring the software delivered to a user expectation. Importance of metrics in SQA. Quality metrics enable teams to quantify software quality, track progress, identify trends, and guide decision making for process improvement. Metric provides an actionable insight into effectiveness of SQA activities, promoting continuous improvement and fostering a data-driven quality culture. Key quality standards. International standards. International standards establish benchmark for best practice, helping organization ensuring consistency, reliability, and alignment of global norms. Industry specific standards. Adhering to industry specific standards, safeguarding sensitive data and ensure regulatory compliance, which is essential for trust and security. Common standards overview. ISO. These standards serve as a framework for a structured software development process, promoting consistency, reducing defect, and improving product quality. Importance of standards. Adherence to quality standards drives systematic approach to development, ensuring reliable and high quality deliverables. Product versus process standards. Product standards ensure the software meets user requirement and expectation, resulting in greater satisfaction, usability, and operational success. Process standards. Process standards promote consistent quality assurance practice, enhancing project management and the overall development process. Key differences. Product standards evaluate what the software achieves, outcome, and the process standards assess how the software developed, methods. Product standards measures deliverables, while process standard guides the creation process. Both are essential for ensuring high quality software that is both effective and efficient development. Implications. Combining product and process standards ensures comprehensive quality assurance by aligning development methods with the desired software outcome. SQA plan overview. Definition is an SQA plan acts as a roadmap, ensuring quality assurance is systematically addressed at every project stage, promoting consistency and accountability. Key components. Object. Clear goals for quality assurance. Scope. Definition of area covered by quality QoS activities. Activities are a detailed list of quality assurance tasks. Roles and responsibility. Assigned duties for QA personnel, and tools and metrics, QA tools and performance measures. Timeline. Schedule for QA activities throughout the project. Each component ensures that no aspect of quality assurance is overlooked, integrating quality practice into project workflow effectively. Importance. Ensure clarity in QA process and align QA activities with project goals and serve as a guide for identifying and mitigating quality risk. A comprehensive SQA plan not only facilitates efficient project execution but also reduces the likelihood for error and enhances final product quality. Plans to project. Adopting the SQA plan to align with the unique requirement of each project ensure that it remains relevant and effective. Conclusion. SQA is not just a final check. It ensures quality at every stage of development from planning through development and maintenance. Future trend in SQA. Looking ahead, automation tools and AI will play a crucial role in streamlining SQA, allowing for more efficient testing and quality checks. These advancements will continue to improve software quality while reducing human error. This is ISO IEC 25002, which I discussed in earlier slides. Plan, do, check. Very simple. You need to plan, then do, and then check, and then act on it. And these are the subdivisions, sub points of the every steps. These are the references. Thank you very much.